Hello dear viewers, this is voice Gary, speaking to you as Buddy from Town's narrator. Since Buddy began his exploration of the cosmos, he has become interested in current news about the universe. Buddy has learned about a new brown dwarf, from reading the article, Astronomers Detect New Brown Dwarf Orbiting an M-dwarf Star, by Tomasz Naukowski, published on phys.org. The finding is reported in a paper published December 7 at arxiv.org. In the article, Tomasz says, astronomers from the Pennsylvania State University and elsewhere have detected a massive brown dwarf orbiting an M-dwarf, known as TOI 2119.01. The newly found object is nearly 70 times more massive than Jupiter, and orbits its host star on an eccentric orbit. Now, Buddy has learned a little bit about brown dwarfs since reading the article. Brown dwarfs are objects which have a size between that of a giant planet like Jupiter, and that of a small star. Most astronomers would classify any object with between 15 times the mass of Jupiter, and 75 times the mass of Jupiter to be a brown dwarf. Given that range of masses, the object would not have been able to sustain the fusion of hydrogen like a regular star, therefore, many scientists have dubbed brown dwarfs as failed stars. Given that they do not have fusion ongoing at their core, they lack the engine which keeps their appearance constant. Consequently, brown dwarfs spend their lives cooling as they lose that gravitational energy from their formation. As they age, they can morph from looking like a low-mass star, to looking like Jupiter. When they are young and hot, a more massive brown dwarf will have an atmosphere with lots of oxides, like titanium oxide, vanadium oxide, and carbon monoxide. Then, as they cool, the new temperatures rearrange the chemistry and we start to see methane gas and ammonia taking over. The same mass object will look very different depending on when you see it in its evolutionary stage. So, why would researchers care about brown dwarfs? Because, NASA points out, it is possible that a great deal of the mass in the universe is in the form of brown dwarfs, and since they do not give off much light, they could constitute part of the missing mass problem faced by cosmology. About this new brown dwarf discovery, in the article, Tomasz explains that a team of astronomers, led by Penn State's Caleb Conyers, reports the finding of a new massive brown dwarf. The new found object, designated TOI 2119.01, was identified with NASA's Transiting Exoplanet Survey satellite, TESS, and its brown dwarf nature was confirmed using a combination of ground-based and space-based photometry and high-precision velocimetry from the Habitable Zone Planet Finder. According to the study, TOI 2119 has a mass of about 67 Jupiter masses and its radius was measured to be approximately 1.11 Jupiter radii. These results yield a density at a level of 60 grams per cubic centimeter. The brown dwarf circles TOI 2119 every 7.2 days on an eccentric orbit, with an eccentricity of 0.336, inclined 88.51 degrees, at a distance of about 0.064 astronomical units from it. The brightness temperature of this object was found to be some 2100 Kelvin. The host star TOI 2119 is an M-dwarf about half the size and mass of the Sun. It has a rotation period of 13.2 days, metallicity at a level of 0.1. And its effective temperature is estimated to be 3553 Kelvin. Based on the rotation period, the astronomers assume that TOI 2119 is most likely between 700 million and 5.1 billion years old. The researchers underlined that high eccentricity of TOI 2119 may be the result of dynamical interactions with a long-period companion, so far undetected. They added that the high mass of this brown dwarf points to a formation scenario through gravitational instability in a disk. More about brown dwarfs. Astronomers think brown dwarfs form the way stars do. Hydrogen is the most abundant element in the universe. Molecular hydrogen will build up into what astronomers call giant clouds, and these become the seed area for new stars. At some point either the weight of the cloud itself, or possibly a shock wave from a nearby supernova will cause the cloud to compress. When that happens, star formation is now taking place. As the gas gets pushed tightly onto itself, it gets extremely hot and fragments into pieces. There are large pieces that break off, those are the big stars, and small pieces that break off. The smallest fragments of this process are the brown dwarfs, at masses less than 75 times the mass of Jupiter. A secondary process researchers think might form brown dwarfs is in a disk around a newly formed star. This process is how they think planets formed and is probably not very efficient at making big brown dwarfs. Brown dwarfs are cold objects compared to stars. At their surface, the highest temperatures brown dwarfs reach is -3000 Kelvin. As a result of being cooler objects, brown dwarfs do not give off a lot of light in the optical. Instead, they glow brightest in the infrared. Every brown dwarf that has ever existed is still around today. A consequence of brown dwarfs lacking nuclear fusion is that they have a calm, sustained existence on the cosmological time frame. Unlike stars that have a given fuel tank of hydrogen at their core that can run out, brown dwarfs just slowly dim down. They don't have an exit strategy from the universe that stars do. There is no giant phase for brown dwarfs and no evolved stage of white dwarfs, neutron stars, or black holes. The ones that are as old as the oldest stars will have very little in their atmospheres since there were very few elements around when the first stars, and brown dwarfs, formed. As well, brown dwarfs have exotic clouds in their atmospheres. The temperatures of brown dwarfs lead to conditions in the atmosphere where clouds of liquid iron, and thick silicates, can form. Famously, brown dwarfs may have cloud decks of conundrum which, if given the right impurity, might be found in the form of rare gems, such as rubies and sapphires. Astronomers have carefully stared at brown dwarfs, as they rotate, and have seen their light dip and change, indicating that there are likely storms raging similar to how we see the Great Red Spot on Jupiter. In the article, Astronomers detect new brown dwarf orbiting an M-dwarf star, Tomasz Naukowski notes, observations have shown that massive brown dwarfs orbiting their hosts at a relatively close distance, less than 3.0 astronomical units, are extremely rare and difficult to find. This so-called brown dwarf desert is constantly studied by astronomers using various techniques, aiming to find other examples of this peculiar type. This concludes Buddy's Space News today. If you would like to follow along to see Buddy from town become Buddy of Singularity, please click subscribe and a like would be appreciated. Until next time, dear viewers, keep looking up and looking back, way back.